everyone. Hope you have gone through my lessons which has been published prior with my channel, and I hope those were assisting you to mingle up with the lessons. So far we have gone through what the matter is, how we divide them, and what properties they possess, and accordingly how are they being classified along with the periodic table, how they have been given specific locations in the periodic table according to their atomic numbers, and how their properties change along a period, how their properties change along a group. So as we all know, behind that then we identified, we can categorize all the elements which we have identified into three basic categories as non-metals, metals and metalloids. So within that aftermath, so we have identified the acidity of the oxide. So if I am coming to that, we can say like this: any metallic oxide will be demonstrating its property as a base. It is a basic oxide. So most of the non-metallic oxide that we identify in our surrounding will be demonstrating acidic properties. So if it is a metallic oxide, it is a base kind of, we can define it as a base, and if it is a non-metallic oxide, it demonstrates acidic properties. So these are the basic two scenarios when it is coming to acidity of the oxides and basicity of the oxide. So that is how you're gonna distinguish between the properties of oxides of the elements. So today we're gonna come into a very lengthy but very fruitful lesson today. So it is valency. So valency, basically, if I am telling you what valency is, the ability to bind with hydrogen, that is the coin which is being given, and also the ability to lose or receive an electron. The ability to lose or receive an electron also being considered as the valency of an element. So basically, when it is coming to valency, an element, either it can give you electrons, an element either it can receive electrons. So when it is coming to the periodic table, so we have, as we have discussed prior, so we have how many? 1, 2, 3, 4, 5, 6, 7, 8 what? Groups. 8 groups within the periodic table. So basically, when it is coming to 1, 2, 3, 4, 5, 6, 7 and 8. So we learned this first group always willing to give one electron out, isn't it? We call as they are universal donors. They are always willing to give away. They are very wealthy people. Always they are willing to give. So what about these people? They willing to give 2. They willing to give 2. And these, they are willing to give 3. They are willing to give 3. These people, they are in the middle class. They are always what? Either you give me okay or else I give you. Everything is fine. So they do not have any conceptions. They are loving to give or take 4 electrons. Right? So we are coming on to 5th group. What? Oh yes, give me 3. And 6th, give me 2. Give me 2. And this one, give me 1 electrons. Give me 1 electron. So here wealthy people are coming poor, poorer and poorest. Poor, poorer and poorest. These are the people who are always seeking for an electron. Wherever we give, they take. So, what about these people? This cornermost category. They've been called as noble gases. Of course, yes, they are noblemen. They neither give, they neither take. They keep what they possess that is sufficient for them to sustain. Like noble people, they are also noble gases. So, they will not be involving in reactions. They do not want to contribute or take electrons. So these are basically their valence will be 0 because they are not going to contribute. They are not going to contribute. Here, basically, now we learn why are they willing to give an electron? Why are they willing to take an electron? That is because when you consider, you learned about their electronic configurations. Each element, irrespective of their whatever the nucleus composition, atomic number, right? So they are willing to have an stable electronic configuration. Stable electronic configurations. So always what they do is they try to move to the closest electronic configuration, right? To the closest. So for example, if it is easy for an element to give away 1 electron and become a noble gas, of course they do. Understood? If it is easy for an element or an atom to receive 1 electron and become a noble gas state, so they do that. Understood? So they want themselves to be stabilized in their electronic configuration. That is why they do this. So when it is coming to this, when they are coming to the first, they give 1. So what is their valency? If they are giving 1 electron out, what is their valency? 1. If they are giving 2 electrons, what's their valency? 2. If they are giving 3 electrons, what's their valency? 3. If they are giving 4 electrons, what's their valency? 4. Then again, these people are ready to take 3 electrons. So what is their valency? Their valency is also 3. And they are willing to take 2 electrons. What's their valency? It's 2. And finally, 7th group, they are also willing to take 1 electron. So what is going to be their valency? That is also 1. Now understood, Kuta? So when it is coming to valency, that is the capacity of an element to give away 1 electron or 2 electron or 3 electron, right? And 4 electron. Similarly, valency also can be considered as the capability of an element to take 1 electron, 2 electron, 3 electron or 4. So simply to give or take 1 or 2 or 3 or 4 electrons. That is called as valency. Valency. Some elements give, some elements take. Understood? That is the simple explanation of this valency. So when you go through your book, there are some examples given. What is the valency of the elements in the periodic table? It has been charted down, so you can refer that part in your book. So I have given you a list also as displays on your screen.